All right, yeah. All right, now let's discuss about help. So help is basically a simple online platform that allows users to search for and review local businesses, restaurants, any other services. So it can be any category. So that's what at a high level help does. And now let's see the basic functional and non-functional requirements, and then we will see how we can break them down and discuss in designing a system. So the requirements, the functional first thing. So here user should be able to search for local, so basically you should be able to search for businesses by name, location, or category and all that stuff. So that's the basic this thing. So you should be able to search for those businesses name by name, using name, location, latitude and longitude, and category, whatever it can be. And then the second requirement is you should be able to view businesses and their review. So basically view a list of businesses, the business details and the reviews on that specific business and all that stuff. And the third requirement is you should be able to leave a review on that specific business. So those are the three core requirements that we should try to meet when we are designing the system for this use case. So coming down to the non-functional thing, so the search operation, whenever they're trying to look for specific business search, the results for them should be within the bounds of like less than 500 milliseconds. So it should be very fast. And then the availability is given higher priority than consistency. It's okay if we are not able to showcase the review immediately or left on the business, but something it should not be lost or something on those lines. So it should make sure that our system is also always up and give better experience. And then coming down to load of our system, we should get ease handle 100 million daily active users and at least 10 million businesses on our platform. So these are the numbers, at least when we are designing a system, we should keep in our as it as an upper bound, and then try to design a system. All right, now we are clear on this functional and not functional. So looking at this, I think the basic entities also should be clear for us. So that's the second point. So the basic entities that we have here is the business. So basically the service, whatever is listed on our platform, it might include details like name, location, category, average rating, and all that stuff. We'll discuss what and all schema fields will be there exactly as we go into our high level discussion. The other is the user, so just the user who can search for businesses and leave reviews on our platform. The review, again, that entity is something which includes a rating, optional text, and all that stuff for a specific business. So these are the like core entities at least we need for us while we are trying to design for this requirements. Now we are clear on this entities. Let's discuss on APIs or system interface that we need to provide to our clients. So first is the endpoint to search for businesses. It can be as simple as the get endpoint. So maybe some businesses and query params here, some searching by name, description or location or another category, whatever it is. And here we have location, category, and the pagination, because we might have a large data set. So it's always good to do a pagination to give a limited amount of data once at a time. So this might return the list of the business list. So this is one simple endpoint searching for businesses, so that their homepage will be populated with the list of businesses. The other thing is, once they see business details, they click on that specific business and they should be able to view the details of that specific business. So it can be either maybe single endpoint like business ID provided, we give business as well as review details, and so that business page gets populated with the basic info and then the reviews of it. Or we can separate it in these two ways. Just one endpoint providing the business and the other endpoint providing the reviews for that business with the pagination logic and all, so that it is properly isolated to each other. So we can design in this way or else this way. It's up to us, whichever it's easier for us to implement. That's something that we can prefer. So that is the second endpoint, just to view business details. The other endpoint is, so now we need to provide an endpoint for user to create a review on specific business. So that's going to be simple post endpoint. So with the business ID, the reviews endpoint, so you can leave ratings. Maybe it can be on the scale of 1 to 5 or 1 to 10 depending upon the stars that we wanted to showcase. Ideally it is going to be on the scale 1 to 5. And the text, if you wanted to leave any comment or text on that thing, this is the field that you can just fill it here. So these are like core endpoints that we need. So now let's take one point at a time from functional requirements and see how we are going to go from all the way from simple system to handling the numbers that we have seen in the requirements. So the first high level discussion point is you should be able to search for businesses by name, location and category. So it's going to be simple, the same the client, and we have the API gateway which will in most cases handles auth related things, rate limiting, routing and all that stuff. And we have here business service. Assume that user the client will trying to hit with the endpoint like businesses, query params and other things which are optional, and it hits our business service, and this tries to query our database. So here business entity can have something like ID, name, description, location, address, category and all those details and all. So these are like core critical components. So client sends a get request through API gateway to business service, and this queries the database for you on this business table. The results are returned to the client via this API gateway. So that's the simple the realization of the first point. Should be able to search for businesses by those name, location and category. So let's move on to the second point, which is you should be able to view businesses and their reviews. So this also it's going to be pretty much straightforward. Same client API gateway and same service, business service. The difference is only the endpoint is going to be get businesses passing in the business ID, and again we'll try to query the database of a business table and then reviews table, and reviews table can have a user ID, business ID for which business ID has given a review, and the rating number, and then the text of it. So we'll just do maybe joins between these tables and give the written results to this client of business along with the review details for that business. So here we are trying to keep it in the same service because the pattern here is both are read heavy, and we wanted to keep it in the same service unless the pattern is very different and something only then we can think of writing a separate service for that. So that's the one main reason keeping it in the same service. So now let's go to this the other point. You should be able to leave reviews on businesses. So this now we will try to separate service into review service. So here the endpoint is going to be post endpoint, businesses passing a business ID and reviews. So why we separated into here the separate services, because the read write ratio, if you see clearly observe, the read is always going to be something like on the scale of like 1000:1. So it's we know that traffic for this service is going to be high, and this for this it's going to be less. So I don't want to have it in the same read heavy services. So that's why we decide having separate service. So it can be simple as review service, and then here we'll just add an entry into this reviews table that we have. So it should be simple. This review services core responsibility is to handle creation and management of reviews, and then because usage pattern is significantly different, like I said, reading and writing ratios. So that's why it's fair to separate in this way depending upon our reasonings, whatever we have. And once the review is created and the confirmation is sent back through API gateway to the client that the review has been created. So we can also maybe discuss here why not have separate database for review service and all. I think given the numbers that we have here, we always should try to aim to have a simple design at meeting all our requirements. Since our numbers are quite smaller, meaning here we have 10 million businesses, assume like each business might get 100 reviews each. So how much? 10 million businesses multiplied by 100 reviews each, it sums up ideally to 1 TB, which is modern databases can handle in a single instance. That's why like we stick to tables in a single database rather than complicating our design. So again, it's again up to our own choice. If you wanted to have separate database, we can have, but it's all again falls back to operational overhead and other the trade-offs that we wanted to make depending upon the business requirements. So yeah, this is the main reason. So I think the four simple functional requirements are met using this simple design whatever we have discussed. Now let's dive deeper and see potentially discuss deep diving of critical points that we need to address in our non-functional requirements. So first thing here is how do we efficiently calculate and update the average rating for businesses whenever users search for that specific businesses. So ultimately, let's say whenever user is trying to look for some businesses, the thing that is going to look for is the rating of that specific business. So it will be very inefficient if you try to do the average rating calculation on every search. It's like repetitive calculating of the rating for the same search query n number of times, which is something not efficient. So yeah, naive approach is this is what we do ideally now. We try to do join between the business table and reviews table by this thing, and every time we try to query and then calculate the average rating. So this is very naive approach, and this is very inefficient. So that is something that we wanted to avoid. Every time we wanted to we don't want to strain our database. So because as the number of reviews and businesses grow, the query is going to be immensely slow and it's going to affect the user performance. So this is something that we don't want to prefer. So what is the alternative then? So other alternative is we can have some periodic cron job which can be running for every couple of hours or of a day or night or whatever it is. So what this does is this periodically updates average. We'll introduce now average rating column in our business table, and periodically it queries this database business table and calculates the average and tries to populate into our business table. So this is ideal, but again here what is it that we are facing the challenge is these reviews again are not real-time changes. So businesses people might again feel the reviews are not updating immediately, and it is something that users will not agree or accept for this kind of use case. So that's why this cron job of introducing this delay of whenever we are running this cron job for immediate reflection is something it's not supporting. So this is why we don't want to go with this periodic update with cron job. So what is the other approach then? So we can go with synchronous update with optimistic locking. So this is something like the question is we need to do the both, that adding new review to the review table and also updating the average rating for business in the business table at the same time. So here we have now the average rating and the number of ratings. So this is something the new rating can be something calculated in this way, like old rating, whatever the average rating that we have here, and multiplied by this number of reviews plus new rating whatever the user has given, and try divide by this number of reviews plus 1. So this way we will try to calculate this new average rating. So this just a few CPU cycles, so it can be done synchronously for each new review. So here again the problem here, what if two users tries to do the review at the same time, so there is a chance that we might end up not considering specific users 1 or users 2's review. So let's take an example. Let's say business has 100 reviews with average rating, let's say 4 rating, and now user 1 reads the number of reviews as let's say 100, and average rating is 4. So user 2 also reads the same number of ratings as 100, number of ratings as 100, and the average rating is 4. Now user 1 submits 5-star. So what is going to be? Average rating was before 4 and multiplied by this 100 plus 5, and here 100 plus 1, 101. So it approximately it became 4.01. Same time user 2 also submitted a 3-star review. So now this is going to be 4 multiplied by 100 plus 3 divide by 101. So this sums up to 3.99. So user say updated completes view with the number of reviews to 101 and the rating as 4.01, and users to average rating to 3.99. So the final state here, it will be now whatever user 2 has done, which is 3.99, and it is incorrect because it actually doesn't take users one's rating into consideration. Ideally it should be 4 because you both has submitted, and it should balance and it should be ultimately back to 4. So to solve this issue of 2 users trying to do the updating of the rating at the same time, we can use this optimistic locking, whatever it is. So here, what is this optimistic technique is basically, we first read the current state of our business. So basically here the state can be here number of ratings, and then attempt to update it. So if while we are trying to do this, if the state has changed since we read it, our update will fail and should fail. So we'll often had a here, that's the something called version number. In our case, it is going to be number of ratings. So that is the something that we wanted to lock on, and we check if the number of ratings are changed or not, and if it is changed, we will just not update, meaning the update will fail, and if it is not changed, we will update. So that's how we take care that no matter what, the concurrency is taken care with optimistic locking. So that's the simple check in our just the update in our SQL query, whatever we will be trying to do in a transaction. Yeah, so yep, that's the simple discussion. So here again we can also think of like why not push it to message queue and then have some consumer pick up that, calculate the average rating and update your business table. That also can be handled, but it's again more of an operational complexity. And even if you see here, given the numbers that we have, the traffic here, we have hardly, let's say it reads to write 1000 to 1, and with 100 million users, we hardly have how many writes per day. It's something 100k writes per day and 1 writes per second. This database easily is going to handle that 1 writes per second. It can easily handle in the magnitude of 5k to 10k with decent hardware is what I'm talking. It can go up to 25k or 50k writes per second. So that's something easily we can handle with this, and that so this average rating calculation is something we can do or calculate in that way. That's how we are going to address this point. So let's talk about the second point now. Now we need to enforce a constraint like user can only leave 1 review per business. So why this is important? There might be some competitors that they wanted to of course want to give lesser review for its competitor, 1 star, and obviously bring its rating down, and people preference is going to change as well. So how can we ensure that we can user can only leave 1 review per business? So a couple of approaches here. Simple application level check. So what we do here, I'll do just some let's say in my application layer, service layer, I'll just do check try to get reviews for that specific business ID, and then check if that user ID is present in that list of the reviews for business or not. If it is so, I'll just not proceed with the writing to reviews table. If not, I'll proceed it to that. So it's something I'm trying to do, enforce the check in my application layer. So this is something, it's not ideal in this case or not preferred. Let's assume there are multiple teams trying to update our table. So maybe some data engineers or whatever, they wanted to update the reviews. So they will not be aware of this application level check, the logic that we have. They will be solely using just the database. So it's something, if something there is a data constraint, we should always tilt back towards closer to persistence layer, see if we can add a strict data constraints there. If not, only then look in the direction of application level. So that's what exactly we are trying to do here. Here we are trying to do here add a database constraint. All we have to do is basically on table reviews, we need to add a strict constraints here, unique user business constraint on user ID and business ID. So this at any cost, make sure that even if you're trying to insert multiple reviews for specific user, it will not allow the entry, because we have a strict unique constraint per combination of user ID and business ID. It should be 1 review for that user. So this way we make sure that a user can leave only 1 review per business. Yep. And now let's talk about the other requirement. The search operation should be with as much as less latency, and in our case here it's ideally 500 milliseconds. So currently whenever we try to search, ultimately how we will do ideally is just do simple query, select star from businesses, and here in our case it's a search by latitude and longitude, and it can be naming wildcard search or description and all, something like this. This query is ideally very slow, because even if we had indexes on latitude and longitude, the B trees indexes, they are ultimately good for single dimensional fields, not for multi-dimensional fields, here in a case longitude and latitude. So and also the number of rows and the reviews are going to go very high in number, and this query needs to do full table scan and all that stuff, which is going to significantly slow the results to the users, and lot of buffering for them. It's not going to improve the experience, and results are not met in the 500 milliseconds latency. So let's see the approaches again. Like I said, basic indexing, it doesn't work out. Like I said, the B-trees indexes ideally doesn't work on multi-dimensional in the fields. So here the other approach is we can choose the Elasticsearch. So the Elasticsearch is basically now if you see carefully observe, we need three types of indexes. One for location, so kind of like geospatial index I might need, something like Geohashes, quadtrees or rtrees, and we need full text search on fields like name or descriptions. So that might use that we need something technique called inverted indexes to quickly search for terms in a document. Then other we need for category, so we need something like simple B-tree index to search by category. So those three indexes are something, or there are many that are supported out of the box by Elasticsearch. So it's ideal to choose Elasticsearch. So we can now search by name and search by this geospatial things, and also search by category. So everything we have whatever we need, and that's why this is an ideal solution to go with, to use Elasticsearch for our searching things. So after considering this, it might look as simple as this. So Elasticsearch here, and we have geospatial index for location, inverted index for full text search, index and category. And here to sync our data, whatever the entries that we have inside our database, we can periodically do CDC logical replication, or then introduce a queue, and then from queue we can try to push it to our Elasticsearch via our worker or consumer, so that the eventual consistency is data will be getting pushed to our Elasticsearch. So this way we can ensure that our search latency is met, and also we have taken care of all types of different indexes. Even now if we don't want to introduce additional Elasticsearch infra or something external dependencies that we wanted to rely on, there is still the other approach that we can go ahead with. So that is with Postgres extensions. So we need the geospatial the indexes. So we have an extension called Postgres, which exactly provides us that, and we need full text search on name or descriptions. So PGTRGM is something that really helps us with. So now it's like we are trying to keep ourselves within the same Postgres ecosystem, so no additional infra or dependencies that we wanted to introduce any components into our system. So it's going to be as simple as this, and this really makes our the development way faster and be efficient, and it's going to be something simple and yet effective to meet our latency of whatever we have. So this also can be taken as a one of the choices things. So there might be scenarios that they don't want to straight away prefer Elasticsearch, and that's the one thing that we can talk about. And also you can just check different types of indexes, like geohashing, quadtrees, rtrees, and which is preferred, something like quadtrees, because here updates are very infrequent, and businesses are clustered into very densely populated areas. And so, and also, like, how do we do the distance calculations here? So we should need to calculate the distance between users latitude and longitude and the business's latitude and longitude. So there is something like we need to calculate distance using Havelsian formula, which is like a Pythagoras theorem, but really optimized for calculating distances on a sphere, which is Earth is like a sphere, like object. So that's something kind of like we more of a questions or discussions that we can go ourselves into and see which one to go ahead with. Is it Elasticsearch or our own this, and then go into intricacies of the details which I just talked about. Yeah, this is how we'll try to improve our latency. And the other point is let's discuss now. So the allow searching by predefined location names, like such as cities or neighborhoods. So this is basically currently what we are doing. Our design currently supports searching based on businesses latitude or longitude, but however mostly users never will try to search in more natural language terms, like for example, let's say pizza in Bay Area or some other things like that. So there now whatever user is just searching, they're not just zip codes, states or cities. So it's something like exact neighborhoods, and then specific points in a location. So here with this search, it's a straightforward that simple radius from a central point or center point is not going to do the work for us. So because city or neighborhoods are not perfectly circular and can have widely different shapes, so it's something that we need a way to define something called polygon, so for each location. So here polygon is nothing but it's going to be a list of points, and it can come from variety of sources. So here to achieve this searching by predefined location names such as cities and neighborhoods, we need to achieve two things. One is going from location name to polygon. So polygon something the example the list of points, like I said, can be GeoJSON. Here type, feature, geometry, and then we can store properties here. So we need to try to maybe let's see how can we achieve this. And the other thing is, once we have that polygon, then we need to filter set of businesses that exist within that polygon range. So let's see how we can see. First thing is, to achieve first point, what we can do is we can just try to create a simple locations table with a name, let's say like Bay Area or Bangalore, whatever it is, and type can be, is it a city, neighborhood, and all that stuff. We can just specify various types here, and here the points, list of points sourced publicly. Example, there's a geo AP5 which will give us all the polygon points which I just specified for a specific area and all that stuff. So, and we need to populate this points with that specific details. There's a something we'll easily get public data based on those areas and the type that we have mentioned. So once we have populated here all of our sources that we really wanted to maintain in our locations table, then we can just use that polygon to filter the business that exist within it. So to do that filtering, it's something that we this Postgres or Elasticsearch, whatever we have decided to go with, they really help us to support this using geo shapes or geo points. So here we can simply add geo shape field to our business documents in our Elasticsearch if you have chosen that, and then the query can be something like for using this bounding box. So geo bounding box, location top left and bottom right. So this is something like this we can search. And also here doing this bounding box search for every request is also not efficient. So to still make it way efficient, we can pre-compute the areas for each business, like whenever we're trying to create or add an admin is trying to add a business or something like that into a platform, what we can do, we can try to pre-compute the areas for each business and then store as a list of location identifiers in our business table. Something like maybe in our Elasticsearch it might look something like this. Let's say business name is startup and location names can be Bay Area, Silicon Valley, SF and all that stuff, and category is something that technology is something I can create here. Okay, so yeah, so this is something like this. If you pre-compute and store it in an Elasticsearch, and now it will become way easier even whenever user searches by pre-defined names or neighborhoods, and then we try to give them good list of results that they will be satisfied with. So this is something we can think through as well when we are trying to discuss of this design. So ultimately the design of our this final design is something it's going to look like this. So client and API gateway, and then we have business service, and we have review service, and the database and CDC will try to populate this Elasticsearch, and then yeah, we have business entities, reviews entities, and location entities, and multiple indexes on our Elasticsearch. So this sums up our discussion on help. Hope at least we covered some good decent points, and hope this might have helped you.